So if anyone can give me a good Pi Day joke, you get a free hoodie. And they're really nice hoodies. Like these are like a $40 hoodie, so it's really nice. Any Pi Day joke?
I don't think they'd come up with a good Pi Day joke. That's just irrational.
Oh! There's one more, so be thinking about it for later. So while I'm getting set up, I'm going to mostly be talking about Kubernetes the whole time. Vendor out of it. We just happen to be a vendor of Kubernetes, but I'm just going to be talking about Kubernetes in general. So a little bit of background about me. I do have a Mac down here, but I have compiled my own Linux kernel, so don't judge me. I used to run Linux. I'm a Ubuntu fan. I currently am using 1604. I haven't upgraded to 1804, so don't hate me. You can leave that aside. So also a little bit of background about me. I went to school for computer science. I went to Virginia Tech. Any NC State fans in here? You guys got beat today. We got beat today, so it's okay. We got buzzer beated at the end 2 seconds to go, so a little unfortunate. I've been in various software developer roles at IBM. Let's see. I did a gig as a developer advocate, which is basically a fancy term for marketing and get to go play and spend the company's money, which is awesome. Eventually, the wife did not like that so much, and I was gone too much, so I had to get out of that. So I turned back into software development and currently lead the IBM Kubernetes Service at IBM. So, yay. It's a fun job. Last night I was up to 2 a.m. working on a problem, so that was fun. It's good times and bad times. Rafa knows. He works with me at IBM. He deals with a lot in the trenches as well. So Kubernetes, by the way, is not easy to run. It sucks running it. I will just say that straight up. Has anyone ever used Kubernetes before? Has anyone ever run Kubernetes? The hands should go way down on this one. Awesome. Okay, so yeah, it sucks, right?
Yeah. What's your pod count? Like, how many pods do you push per minute?
There is actually a theoretical max. What is it? No, it's actually based upon the Linux kernel. There was some weird limit with it. I think it's 512. I think it has a limit actually. So just a little Kubernetes thing. So a pod is a collection of Docker containers. Actually, in this case, it can be containerd now. So I hate Docker. Docker sucks. It's a wrapper around containerd. Docker it sucks. It really does. Like you try running that thing in prod, it falls apart so quickly. You're laughing because you know it's true. But yeah, containerd is like the future of Kubernetes. It's basically a fancy wraparound C groups, and C groups are wonderful, as everyone knows. But yeah, Kubernetes is a pod. I should just jump into things. But this is going to be very, very informal, so please raise your hands and ask questions. If you interrupt me and have a really good question, I might give you another hoodie, so enjoy. But yeah, a pod is basically a collection of running containers. So a pod can be one container, which is usually one container. Sometimes it could be like 5 or 6 or 10 or whatever you want. I should probably just jump into this now. So we're going to jump into Kubernetes deep dive. Kubernetes is not magic, by the way. It's very hard to run. It is magic in some ways, but running it I would never suggest doing ever. Go to a vendor. Don't run it yourself. It's miserable in production. It really is. Running a small little like Minikube. Has anyone ever heard of Minikube before? Minikube is great for development purposes. It's great, but running it in production and keeping that thing up to date, it's literally, excuse my English, hell on earth. It's not fun. But Kubernetes is basically like voodoo black magic for running containers. It is awesome. There's all these things coming out in the community. It's something called Knative now. Anyone heard of Knative? Oh, yay, more hands. Awesome. So Knative is basically like the evolution of Cloud Foundry, but on top of Kubernetes. It's a really awesome project. And it's built on top of Kubernetes and makes even more fun black magic with applications. So here's actually what Kubernetes is. Kubernetes is this basically fancy orchestration layer for containers. So be it Docker containers, containerd now, and the latest version of Kube, I think that went out in Kube 112 or 111. You can run containers. You can run some basically every cloud provider out there. AWS, us, Google, Azure, I guess I said AWS, Microsoft, you name it, VMware. It runs on bare metal. It runs on OpenStack. Really any hypervisor you want. You can run it on Power. You can run it on your, I think Rancher Labs just came out with this sweet little distribution the other day. I think it's called K3S, and you can run a Raspberry. You can run Kube on a Raspberry Pi now, which is really cool. So if you wanted to run some embedded stuff at home on their Raspberry Pi, maybe for that project for the doorbell, you can run it on Kube. So Kubernetes it's really kind of taken off in the community. It's kind of the next evolution of, and I would call it the operating system for the cloud now, really. It started at Google. This is a common misconception. Google does not run Kubernetes internally. Has anyone ever heard they do? No hands should go up right now. They don't. They run something called Borg. It's basically Borg. Kubernetes is a stripped down version of what Google runs. It's kind of sad. Google supports it, but they don't at the same time. But Google is a great maintainer of the project for the most part. 100% open source, written in Go. Has anyone ever written Golang before? Awesome. It's a wonderful language. I love it. I did Java in college, and I'm classically trained in Java. I hate C++. I hate C so much. I hate dereferencing pointers and memory allocation, but Go kind of gets rid of the memory allocation, which is so wonderful. It's almost voodoo black magic. It's a wonderful language. It's not meant for everything, but it's wonderful for Kubernetes. The cool thing with Kube, it's all based upon plugins, but it didn't do what OpenStack did. Did anyone ever use OpenStack before? Sorry if anyone ever wrote code for OpenStack. I'm hopefully not offending anyone. OpenStack kind of went crazy with the way they did vendor support and allowing plugins, and they tried to make it work for everyone. But so Kubernetes kind of took a page from their book, and they didn't do what OpenStack did. So they left the core code base vendor neutral and had a bunch of plugin points, which is wonderful. There's a fun little video. I'm not going to show it, but go to YouTube and type in, what is it, Children's Cartoon to Kubernetes. It's a good 5-minute video that explains everything about Kubernetes. Oh, well, it was a dad at, I want to say it was Rancher, but maybe not. But he created this little animated series for his daughter to explain what he did at work. It's the cutest little thing. It has like little animals in the ark getting carried across the ocean, explaining how Kubernetes works. It's really cool. Watch that. You'll learn what it is.
There's a book version of it, so it's a good stocking stuff for kids.
Thank you. Ooh, that's almost hoodie worthy right there. I'll have to keep that in the back of my pocket. So, so what Kubernetes basically is, it's a bunch of decentralized kind of microservices. Buzzwords, I hate buzzwords, but I'm going to use them a couple times. So what Kubernetes is basically this fancy API server that controls access to a database. And this database happens to be etcd. Has anyone ever heard of etcd? It's really, really awesome. It's basically event-driven. I guess it's like a fancy version of Kafka, kind of, in a weird way. It has some awesome performance characteristics, but you can shoot yourself in the foot really quickly with it. But this API server kind of controls access to this database. And the way Kubernetes kind of works is you set listeners on different types of events, and this API server responds to things and makes those things happen. I'll get into that in a little second. But the most important thing about Kube is something that's really the scheduler Kubernetes has. It's not the best scheduler. It's evolving over time. But it basically learns how to place applications on different pieces of hardware, be it bare metal, virtual machines, Raspberry Pis. It doesn't really matter what it is. It can be a power system. It can be some weird architecture. I mean, if Sun even has systems around, you can run it on that too. But basically what Kubernetes does is it has a herd of cattle. I like using this a lot. So think of your VMs and bare metal machines as herds of cattle. We like talking about this all the day. Sorry if this is a little gruesome. We have machines die in production all the day. We just shoot them in the head and replace them. It's just replace and get rid of a new one. We have in production, what is our biggest cluster? I think it's like 300 or 400 nodes now, and when one dies, we just replace it, just order a new one, and we don't even try fixing it, just replace it. So what Kubernetes basically schedules all your different containers to different running machines at the same time, and you can get fancy and say, I want a machine, my application running in, let's just say DC, spread across 3 different availability zones. So Kubernetes will make that happen, and it's all done within YAML. It's super, super simple. I'll go into that in a little bit. So I kind of went through some of this, but I'm going to skip this actually. This is a lot. We'll skip that. So actually, this is some good things to go through. So I talked about this earlier. So a pod is basically the lowest level thing inside of Kubernetes. So a pod, it can be a single container, be a Docker container D. It can be just a simple little application that says "Hello World," a website, or it can be this crazy complex data crunching engine. So on top of a pod, a pod has its own IP address. It has its own shared memory. So this is the cool thing with a pod is, I was talking about a container can have multiple containers in it. Each inside of a pod, a container can talk to another container inside the pod. So if you want to have some private networking besides your app, you can do that. So if you have a database, for example, that wants to talk to your back-end Java processing engine, you can do that over a private namespace or private IP range. You never have to go outside on the public network. And you can actually do a shared memory range as well, which is really cool. So the level above that is something called a replication controller. It's basically Kube's fancy way of placing resources across the Kube cluster. So a replication controller, it's kind of a new thing in Kube as of 1.8 maybe. But it basically says, I have this set of resources, which is a pod. It's usually tied to a particular version of a Docker image. So be it web application v1.1, for example. When you want to roll out a new version of your app, you can literally delete that thing. It's gone. And Kubernetes will do a rolling deployment of your application, which is really, really cool. So you won't have any downtime in production, which is awesome. Next above that is something called a service. So think of this as, I'll just say AWS. This is easy to think about. How AWS has load balancers. So you spin up a VM inside a load balancer. Probably lots of people have done that. So a service is basically a way to expose your application, either inside of Kubernetes or outside of Kubernetes. I'll talk inside of Kubernetes first, and we'll get fancy after that. Inside of Kubernetes, so a service can be inside your Kubernetes cluster. So it can be just available to your applications. It doesn't have to be exposed to the outside world, which is really powerful because you could have, let's say, 100 instances of your backend Java app running and 2 instances of your front-end web app running. That's probably actually backwards, actually, but that's fine. The cool thing with that is everything can be done over a private namespace, private IP ranges, and never has to go out to the public internet. You can actually skip like authentication on a lot of those cases because you don't have to go out to the public internet and worry about anyone hacking your stuff. I would still do like TLS certs or something just for safety. But it's a nice way to expose services inside your Kubernetes cluster without having to go out to the public internet. A service can also be a load balancer. So a load balancer is usually an IP address, or in Amazon, it's a CNAME, usually to an IP address. Or if you want to get fancy, Kubernetes provides something called an ingress controller. Has anyone ever heard of an ingress controller? Oh, yay, wow, awesome. So an ingress controller basically is, it's basically a fancy version of Nginx. And so an ingress controller basically says, like, give me your application, what port you want to run it on, and what's the path for the application. Super, super simple, and it's all done in YAML or JSON. You don't have to worry about mucking around with the Nginx config file because that's not fun. No one does that. It's horrible. I hate doing it. And you usually get it wrong. But Kubernetes makes that super, super simple for you, and you don't have to worry about scaling your ingress or scaling Nginx. You don't have to worry about your application being available across multiple AZs. It's super, super simple.
Does a load balancer require a controller? I've noticed that you can do load balancing on AWS, GCP, DigitalOcean, but I'm pretty sure that code base is the same.
Yes, that's a great question. Ooh, that's almost hoodie worthy too. Oh man. This is going to be tough now. So that's a great question. So I'll repeat the question. So an ingress actually requires a controller. So this is where vendor-specific things come into Kubernetes. So this happens when you need storage or networking. Kubernetes does not put that into the main code base just because it's not a good idea to maintain code like that. But basically the answer is yes, you do require a controller. So we write our own ingress controller. We open source it. Everyone else, for the most part, does as well. There's really no fancy logic there. It's how do I receive an event from the cloud provider's API, and how do I spin up or connect to their load balancer or their ingress. Ours, we actually run the load balancer in cluster, so you get a bunch of fancy layer 4 and layer 7 stuff. AWS uses their load balancer as a service. I think GCP, Google does the same thing as well. But things like storage and networking, those are very, very cloud provider specific. So like when you run Minikube, for example, it doesn't have an ingress or a load balancer. I think it actually has a load balancer, but those things are very, very cloud provider specific. So whenever you run on a cloud provider, they provide those things, but the way Kubernetes is set up, you don't have to usually know anything about the implementation or anything coverage. You can use a common syntax. I can go deploy an application on IBM Cloud or Amazon. It works exactly the same way. And I don't have to know anything about Amazon or IBM to make it happen, or Google for that matter. That's the cool part about Kube. And storage is kind of the same way as well. So storage inside of Kube can be backed by really anything. It depends on the cloud provider. Some people use block. Some people use NFS, some people use fancy versions of SSD, or I don't know what else is out there nowadays with storage. But it's all, again, cloud provider specific. And those are all done in common, simple ways. Great question, though. Jeez, I love it. OK, so Kubernetes has some other cool things. So when you has anyone ever run like Docker containers or tried running like applications in prod and having to deal with tons of secrets and secret injection and running out of environment space and Docker, and it's fun. It's not really. You actually hit a limit eventually. It's horrible. So Kubernetes kind of provides a solution for that. Yeah, it's actually pretty cool. So you can have something called secrets inside of Kubernetes. They're basically base 16.4 encrypted inside of Kube, but I'll go down a little bit of a rat hole here. You can actually back them with, I'll say this for you, an HMAC provider. So basically something like Vault, for example, you can back with Vault. And if you delete the key from Vault, those secrets are gone forever. You can't ever recover them, so it's kind of cool. But Kubernetes also provides something called a config map, and you can use that to inject secrets into your application. Config files, so your usual .conf file, your usual like JSON file, fun things like that. So you don't ever have to have application, or I guess runtime specific information built into your app. It's just, for example, like we have different information running in Dallas versus in London, for example. We have different credentials to connect to our databases. I will skip the rest of this stuff for now. So I'm going to probably spend most of the time doing a demo and kind of deep diving into how Kube actually works, but I just want to give a high level on it. So this is a fancy marketing slide. I did not make this. I don't know how to make a slide like this, but I guess this is some super high level things about Kube. I just want to make sure they're covered. So Kube provides you scheduling. So this is something we do in production. So let's say you have let's just use this room for example. Let's say you have a server in this room running, and then there's a server in the room next door running, and there's different power circuits to each and different data fed to each, whatever that. So they're completely separate, independent. They won't go down. With Kubernetes, you can actually say, I want my application to run on 2 independent servers. So if that server gets shot for some reason, my app won't go down. So you can do fun, cool scheduling stuff like that. With Kubernetes, you can also do self-healing with your app. So what that means is you can actually say, like, hey, Kube, I'm just going to use Java as an example here because it's horrible with this. And I'll say Node.js as well, too. Most specifically Node.js. Memory management, and those, I hear some laughs because it's funny. It's very true. It's not good. So you can say, hey, Kubernetes, like when my app hits a gig of memory, just shoot it and replace it. And it's a lazy man's way to, I guess, lazy programming sometimes. But instead of trying to fix it out of the memory bug, maybe it doesn't really matter anymore.
Garbage not a collection.
Yeah, exactly. Yeah. I guess it introduces some bad, maybe CS 101 things, but I mean, running something in production, maybe you don't have time to go deal with that. I mean, I guess the other good thing about it is you can actually set up like checks inside of Kubernetes. Like you can say, hey, like I have a health check. Come hit me every 5 seconds and see if I'm alive. If for some reason that doesn't return what you want, you can say, hey, kube, shoot it, and replace it. So it's wonderful in the fact that you never really have to go watch your application run anymore. Kube will do it for you. It's kind of awesome. Kube has auto-scaling kind of built in, and I'd love for you to call me out on this, but it doesn't really have it built in. I'm looking at you again. So auto-scaling, it's kind of built into Kube, but again, it's cloud provider specific. But you can say, Kubernetes, here's some lower bounds on my throughput and memory and CPU utilization. It'll make sure it always keeps that. So it'll scale up and down your app as it sees fit, which is really cool. So service discovery and load balancing, this is, I guess, the holy mecca of like what Netflix was doing years ago with the Asgard stuff and all their OSS stuff. Service discovery has never been an easy thing. It's still continuing to evolve. At least with Kubernetes, it's very easy to do with services. You can always have always access your application or your database on /DB port 1001 if you want to. It can always be that. You never have to worry about it. And load balancing is kind of built in as well. Rollouts, this is a great steamroller. I love this. Someone knew what they're doing. Rollouts and rollbacks are really cool. So if you set up your application correctly in Kube, it's pretty awesome in the fact that you can do a rolling rollout production of your application. Let's say you're running a Tomcat app, for example, and you want to make sure you're taking traffic and you don't shoot a connection in process, and then make sure the new app comes up and takes traffic correctly. Kube will do that for you all by itself, so you don't have to worry about draining connections and removing a node from a load balancer. It'll just do it. Makes it super, super easy. And I kind of touched on this before, secret and configuration management as well. Any questions on that? I know that's a lot to take in.
I've heard of automated rollouts, but how do automated rollbacks work?
That's a great question. Really like a whiteboard, actually. Can I put the screen up?
I know that if a pod is not whiteboard.
Oh, yeah, this works. Yeah, let's use this one. So inside of Kube, the basic the highest level thing, I'm just going to do this giant box. Something called a deployment. So this has like the name of your Docker container, like where you're pulling it from Docker Hub or whatever registry you're using. Inside that says like how many versions of my app I want running. For example, let's say 3. 3 is kind of the recommended number. I can go in that later if anyone wants to know. Inside of this, it's, let's say Docker Hub, I think Hello World. That's my registry. That's my container I want to run. Inside of that, I might have like pointers to like password or something for my database. So when Kube sees this, what it does underneath the covers, this is what I was touching on earlier. It spins up something called, I'm just going to put RC here, replication controller. Inside of that, this is basically the state and time of your application. So it's Docker Hub version 1, 2, 3, 4. Inside of that, there is something called a pod, and that's what I was touching on earlier, pod. So that's literally the running like Docker container right there. And in this case, I have 3 of these running. So if I want to roll out a new version, Kube will slowly start draining these things if you have it set up correctly. But it will keep this replication controller around. If you ever want to go back to it, it'll spin this up. Yay, new app's running 1, 2, 3, 4, 5. Put some more pods here. If I delete this thing, I can actually scale this thing back up. It saves, by default, it will save, I think, an endless history of them, but it's generally a bad practice. You want to prohibit Kube to let it keep no more than 10.
So you're telling me that you can have multiple replication controllers under the same deployment at the same time?
Yep, and Kube will scale these down so these are no longer taking traffic. And then it will send traffic over to these guys. And the cool thing is, if you really, we can actually do it. It's actually kind of fun to watch this. So Kube will actually shoot, it will kind of choose one of these pods at random. Let's say pod 1. It'll start bringing up another pod over here, and it'll repeat the process until traffic's completely moved over. So it's really cool.
That's for all the connections to be done before it kills.
Great question again. Yes and no. It depends. You have to kind of tell Kube where to look to see if connections have been killed. You can set Kube up basically in this fancy deployment YAML, this top level
So
thing.
it's configurable.
Yeah, it's completely configurable. You say like, hey, my app needs to check on /healthz, that's a common endpoint, to see if it's alive or not. And you can also look at like, you can tell Kube to send sig term to your application so your app can wait until it sends back termination signals as well. But again, that's all highly configurable. A lot of these things aren't really documented that well in the community, so there's kind of like, I should have a list of like 10 best tricks to run your app in prod, really.
Do you have people that run like replicated sessions amongst members in a pod?
Yes. Oh, wait.
Well, like Comcast running, like maybe say, you know, maybe you have a state-aware application, you know, it's got to have like a session, a persistent session.
Yes. So that's based upon, again, this is I guess a little bit of a cloud provider thing, but most cloud providers support this. The ingress controller, the load balancer, will support sticky sessions, so you can always send it to the right Tomcat instance if you want.
And that will survive through rollout and rollback?
If you back it correctly with like, I guess in this case, like something like Redis or Memcached to back your sessions, then yes, it would. But if you don't have it backing with something like that, your sticky session's gone. Yeah.
So not a question, but just on a note on the deployment to answer this question, like we can use some parameters like max surge or initial min ready seconds to sort of control like how many pods I want to move up and do a new one before I actually kill the old one, so that way you can sort of have a controlled fashion.
Yeah, exactly. That's a wonderful point. I'll repeat that. So again, this is getting into some fun like prod running stuff. Man, I should just talk about this the rest of the time now. How to run an app in prod. I guess another talk. But so yeah, all this is highly configurable. You can say like, hey Kube, I want you to only spin up one container at a time and wait until you can say like this timeout time between each one comes up. So it's wonderful for that. So if you don't want to surge your database, for example, or let's say your app starts up and you do pre-fetch a bunch of stuff from an external service or your database, you don't want to flood it. It's a perfect use case of that. Any other questions on this? I mean, this is actually super core foundation. I could talk about this for the next hour and a half, really.
Controllers versus sets. You up with this?
Okay, great question. So the question, I'll repeat the question. So there's Google used to have this thing in, I guess it's still technically in Kube now. It's being phased out. It's called a set. It used to work inside of a deployment. Kube is phasing it out right now. They've kind of been replaced by replication controllers. If you go look at some of the core examples in Kube, I think Kube DNS is the most notable one. I think that's still on a set, which is odd that they haven't moved it up yet. But that's being replaced by Sky DNS, another discussion. But yeah, a set is basically the old version of a replication controller. Use a replication controller instead.
You say it was replaced by Sky DNS?
Yes.
I heard it was Core DNS.
Oh yeah, thank you. Oh, that's actually hoodie worthy. Correcting me, I love it. You deserve a hoodie for all the questions. Yeah.
A little bit, you guys talking about the sessions.
Yep.
Talking about easy scalability and draining connections and such. So, so you mentioned the queues. I was wondering, so does that have to be like in its own replication group, or it's like a centralized object where you keep the sessions? How are you managing that when you're tearing down some?
I'll preface that before I answer that. So Kube works best with what's the term I'm blanking on? It's like the 11 principles to a cloud native app or something.
12-factor?
Yeah, 12-factor app, yeah. So Kube works really well with that. When you start doing stateful thingies, it starts getting a little weird. But you can do that. I wouldn't recommend doing it personally, but you can definitely do that with Kube. Like, we've had this situation where we have this horrible old legacy app and we have to back it with session persistence. It always has to go to the right node. Long discussion why. We would love to shoot it, but we can't. It's backed with Redis, and we kind of persist the sessions across that.
They're always horrible legacy apps.
Yep. Everyone has them. I mean, if you go read Netflix's blog, like, they talk about this horrible on-prem like accounting database they still have they can never get rid of. You can never move like 100% to the cloud.
So if you had a situation where you had to kill some machines in a modern app, you would say just let them log in again or something? Just for the sessions to try to keep it? Or I guess which of the 12 factors would actually play into it?
Yeah, I would try to. I mean, you can. There's ways you can get around it. You can do cookies to carry state instead, like and back that with Redis, for example, instead of like, I guess a true like session and Tomcat. I mean, that's a way around it at least. But I mean, this is just me personally. I'd rather force someone to log out than completely kill them completely. But that's just me.
Yeah, I didn't have a more important example off the top of my head, but.
No, that's a good philosophical discussion. It's like, do you kill someone completely or just force them to log back out and get them back on the same page? I don't know.
Not data form data.
Or just don't use sessions, I guess.
So in the self-healing phase, when you are trying to kill something,
Yep.
is it possible to dump it somewhere to get information why it is
Actually, technically, yes. So when Kube shoots a pod, it keeps these things around, these replication controllers around for, depends, I guess, how long you want. But underneath the covers, Docker will keep the pods around anywhere from 5 minutes to like a day. It really just depends what's going on in the system. The cool thing with Kube, you can go back and look at the logs, and you can say logs-p, and then you can go see everything about the previous running container if you want. But it really depends upon Docker, if you're using containerd, what's going on there, really. Any other questions on the funness with all that, with pods and replication sets? I guess I should mention, you can do stateful things inside of Kube, actually. There is a different type of descriptor used for that. It's something called a stateful set. And it's actually meant almost for that case you were talking about earlier, where you want a long-running app, let's say a number crunching app, that you don't want to get shot and replaced all the time. It's meant for that specifically. It's a way to keep data around for a long-running app. Kube also supports cron jobs and jobs, so a job can be something that spins up really quickly or runs 5 hours, 2 days, whatever, it doesn't really matter. And cron jobs is just a wrapper around that. There's something called daemon sets, which basically, this is really cool in the sense of like monitoring your cluster. If you install, I mean, Prometheus is a great use case of this. I'll just talk about Prometheus. So Prometheus basically is this fancy scraper that scrapes metrics from a bunch of running nodes inside of Kubernetes. It works really, really awesome. But if you want to pipe up off logs to like, I'll say like LogDNA or Sysdig or name your favorite logging or monitoring company, you need something running on every single Kube node in the cluster to basically scrape var log containers and scrape all the logs and send them off. Something that can be done with something called a daemon set. So a daemon set basically schedules some type of container on every single node in your whole Kube cluster. So it can be really, really powerful if you want to like scrape logs or do some crazy monitoring stuff to make sure no one's hacking you. You can do fun, cool stuff like that. Yeah?
How do the stateful sets work with rolling state between deployments?
That's a good question. It didn't work until Kube 112, which got released 6 to 8 months ago, I think. 113's out, 114's I think just came out. But yeah, it did not work until very recently.
Okay.
Yeah, it's always ever evolving. Good question though. I wish I had another hoodie for that one.
Isn't the intention of stateful sets, like, I think the default is recreate instead of dual rolling?
Yes.
So you delete one, make sure that, create a new one, make sure that one's healthy, and keep rolling that way.
Yeah, so Kube will copy over, it depends what persistence you're backing that set with, but usually like it's like block or some super fast storage. In that case, it will reattach that block volume, technically a PVC, that volume to your new running container so the state's copied over. And so the great thing is like with Kube, since it's all open source, like exactly to your point, like it didn't work, but then someone's like, hey, I want to make it work, and cool, why not?
With the stateful set, if you push a new config, does it apply to config or does it restart the container?
It's dependent upon your YAML, actually. I'm trying to remember what the default is and with it. I cannot remember off the top of my head, but it's all that's configurable again. All these settings I went through earlier, and especially that one as well. Like, there's defaults for them, but you can almost override anything and like It's one of the great things with Kube, and one of the horrible things with it, you can shoot yourself in the foot super quick if you don't know what you're doing. I should just give a presentation on that now. Any more questions on that? I could just keep talking about this as well. Yeah.
It's a great way to get, I mean, Minikube is an option, but what are other great ways to get started with Kubernetes?
It really depends if you want to run something in production or not, I guess. If you want to run something in production, go pick your favorite cloud provider and go with what's cheapest or where you need to run for data residency or, I mean, different cloud providers have different things about upgrades. Upgrades suck with Kube so much. Different cloud providers do different things with it. There's two types of upgrades in Kube. So your worker nodes are cattle, but then we call it the master. I think Google calls it the master as well. It's basically the director of the evil lord that tells everyone what to do, your wizard that tells everyone what to do, your unicorn, I guess, actually. It kind of directs everyone, and that thing has to get upgrades as well as the cattle have to get upgrades. And the master is a hard bit to upgrade. The workers are the cattle, the workers, we call them workers. Those are pretty easy to upgrade. It's like shoot and replace, drain traffic, yay, everything works again. The master is hard. And Kube kind of has this notion of N-2. That's kind of supported for upgrades. Anything beyond that, good luck. Seriously, yeah. They deprecate APIs, and you have 2 versions to move up. If not, you're AWOL. You're out of luck. I guess that's one of the bad things with Kube. It moves so quickly if you don't stay up to date. But going back to your question, though, yeah. So I would pick your favorite cloud provider. We make upgrades super easy. Like we allow you to choose when to upgrade your master. We auto apply security updates. Obviously, like there's a recent one that came out, I think 2 or 3 weeks ago. We had an update out in like 2 days. So those things will auto apply for you. But anything that's on your master or your worker, you have to apply those. We will tell you they're there. We'll let you do it, but we will not do it ourselves. We don't want to take down your application.
Any customers using OpenShift or anything like that?
Yes. I can't talk too much about that, sadly.
Okay. Right.
I will get in trouble by our legal team. We're merging with Red Hat, so I can't say much about it. TBD, just watch, I guess. I think it's supposed to close later this year, but just watch the news. Yeah.
So going back to your point about master upgrades, is that where like a multi-master deployment would be a worthwhile thing to do in that particular instance?
Great question. Yes, you can run a multi-master deployment inside of Kubernetes. However, it's not the easiest thing to do. So the problem is it's not like you can run multiple instances of the API server. You can run multiple instances of the database. That's not the problem. There is actually a problem inside of Kubernetes where you can't actually point the master to a CNAME. That's the problem. Like you have to point it to an IP address. So we did a little dirty trick. We run an HA proxy inside your cluster that resolves a CNAME and then bounces it around to health-checked IPs. Dirty little trick. I don't mind sharing it if anyone wants to write that down. I don't really care. I think it's recorded. Yeah.
So with your managed Kubernetes offering, how do you provision the control plane? Are you running just vanilla Kubernetes, or is it like, are you running the control plane on another Kubernetes cluster, like Kubernetes?
Great question.
Kubernetes,
I actually had a slide about this. I made a special slide. Let's see, is it coming up? Let's skip through that. Customers, whatever. We're actually using like, I guess 3 layers of inception. We run Kubernetes on Kubernetes on Kubernetes. It's really kind of weird, but we're not doing any layers of double virtualization, so I'll kind of explain how this works. Maybe just erase this. We are not using K3s, actually. We actually just run vanilla kube, and we just drop in our load balancer and our storage plugins. But the way we do it, and this is not confidential, you're more than welcome to take pictures, do whatever you want, I really don't care. So we have this fancy, it's basically this thing called Admiral. It's like our fancy, we like ships, and everything's named after ships. We have different ship names, Admiral, Cruiser. patrols, and now we have a frigate. There's different ship names for different types of clusters, so it's really kind of confusing. This admiral is basically like the worldwide director of everything. So again, coming back to your fancy unicorn. So he kind of directs these regional setups of something we call carriers. We chose the name carrier because it's big warship and sounds fancy. We have a couple of these running in regions all around the world. So we use Kubernetes to stand up Kubernetes in that instance. And when a customer U comes and provisions a kube cluster, we stand up 2 different type of clusters. A cruiser, and I'm just writing these because it's fun, or a patrol. One of those means you're a free cluster, you get less resources. The other one means you're a paid cluster, and you get an ingress and load balancer, and you get storage, and you get more resources. So as a running customer, you have been provisioned 3 layers down through Kubernetes. So we're managing our infrastructure that's managing your infrastructure on top of Kube. And Google actually wants to do the same thing. They run everything on VMs, but they're moving to the same architecture as well. It's kind of fun. It gets weird.
So where does your control plane live?
So that's a great question. So we do a managed service. So your workers, let's just draw like a bunch of little workers inside of here. So we run your master HA across a metro, for example. Let's take Dallas as one of the metros we support. So we'll run your master across 3 different AZs in Dallas, for example, and it'll be load balanced, HA'd, everything. We'll take care of it. We manage it. If something goes down, we'll bring it. We'll fix it for you. So we manage your master. You can't touch your master. That's pretty common across cloud providers. Google does the same thing. Amazon doesn't. I won't go into why there. Azure does the same thing for the most part as well. There's some downsides with it. You can't control a lot of your advanced kube settings. Like if you want to get in there and turn on some beta features or some alpha features, it's not really supported. We let you do it, but there's big like things you have to sign that says you're going to screw yourself up. We're not on. It's not. Just stay away from it type of thing. But the nice thing with the managed master is we'll guarantee it to be up. We'll take backups for you. We'll guarantee to be up all the time, and you never have to touch it. The master is what sucks in Kubernetes the most. The workers are easy.
So you do it for a tunnel?
Yeah, so the way this works, basically everything's done over fancy VLANs we have some fancy networking. So your customer cluster is over here. We'll just put a cruiser over here. We have some fancy tunnels running back and forth between our account and your account. So encrypted, fancy 2048 keys that encrypt everything, like you can't get hacked.
Can you lock down the API server?
Yeah, so the API server technically has to be open on the public internet, but it's only open to us, and then you can open it up anywhere else than you want to.
Okay, so it is locked down though.
Yeah, by default, everything's locked down. Has anyone heard of Calico before? So there's lots of different networking overlays inside of Kubernetes. We use Calico. Calico is kind of the best one out there. You get almost line speed. I think it's like 95% line speed of like a 10 gig link. So that's great. You can never get 100% with an overlay. It's just impossible. If you can, like, I want to hire you today. But seriously, yes. It's almost impossible, yeah. But yeah, we use Calico to lock down networking policies. It's basically like a fancy front end for IP tables, really, at the end of the day.
Great.
Yep.
You can talk about Docker and Docker?
Docker and Docker?
Yeah.
Running Docker?
Instead of running Minikube, you run Docker and Docker.
Oh, like Docker and running Docker and Docker Compose, or?
There's a JPETAZZO keep it full, and then you look at DIMD, Docker and Docker.
Never heard of it.
Instead of Minikube.
Okay. Yeah, I've never heard of it.
Not targeted with Mac OS usually.
Maybe I'm on a Mac, that might be why it's not.
What I do for local development, I actually run Docker on my laptop just to compile Docker images every now and then. I mean, I give it only 1 gig of memory, and I have 16 gigs on that thing. I don't want it sucking anymore. Like, it's already enough. I run Lightroom on there, and that takes like 5 gigs itself. I mean, any good like CI process, you just build your, like, let's say you're doing, let's talk about Java. You would get your tests running locally, git check-in, send it off to your favorite CI system. I'll go through that in a little bit. And you wouldn't actually build the Docker container locally, so you don't ever need Docker locally. It's just in your CI system. It builds the container and pushes it to your favorite registry. Docker Hub, Quay, us, whatever. It doesn't really matter. Any more questions on? Yeah.
For a really, really small cluster, would you, like, 3 nodes big, 4 nodes big, would I get more value out of making SED an external cluster, or would I get more value out of running multiple masters?
So we get this question from our internal teams as well. We see different things based upon what different teams do. My general solution, our general recommendation is running more clusters, honestly. And the reason for that is there's Watson. I mean, everyone's heard of Watson, I hope. But they run this giant freaking cluster, and it drives this up the wall. It has, I think it's 700 namespaces inside a kube. So namespace is basically like a fancy way to carve off like a C group, I guess, kind of, if you want to think of it like that. But they run these giant clusters that have thousands and thousands of workers, and it's so hard for them to manage and carve up access control on it. Just spin up multiple clusters. Like, you're not going to pay much more. Like, you're going to pay like maybe an extra $5 a month for another cluster. Like, just do that. It's way easier, please. I beg you. Don't spin up a large cluster that has that many namespaces in it. Yeah.
So, question regarding the cluster upgrades. You said like master is probably difficult workers are super cheap or cheap. So, let's say you are running a multi-master, multi-zone high availability cluster, and you want to upgrade your workers, but you have like a bunch of different snowflakes in your cluster. Like, okay, this thing needs to happen this way, and you need to first upgrade this component. Only then you should be able to upgrade this component, and things like that require manual intervention. Like, in ideal scenario, you would just do a rolling update and Kubernetes will take care of the update. But in such situation when you have a bunch of snowflakes and requires intervention, like how should that situation be handled in like 100% autonomous way?
Can you give me a more specific example so I
like
could talk through?
You have a bunch of edge nodes which need to be updated first, and then you have like tons of services, and services, maybe not all of these services are using concepts like for disruption budget, so you need to keep in mind, minimum number of available components are running, and you need to, maybe think
So
about
lots of dependencies.
lots of dependencies, yeah.
Yeah, so you'd be scripting it somehow, right?
Yeah.
How
Yeah,
do you
like
actually
maybe
script that?
At some point, you'd have to script that, but I'm going to talk through something you said really quick, the concept of edge nodes. Has anyone ever heard of a concept of edge nodes? Maybe one or two hands. So basically an edge node is a way to do like a controlled ingress into your cluster. So you can basically have these giant like boxes on the outside of your cluster, like have like 20 gig redundant links that are coming into them, so you can crush like 40 gigabits a second of bandwidth. Like if you're doing that, that's awesome, but very few people do that. But you can have these giant edge nodes on your cluster, and then these tiny little guys behind it that don't need as much throughput coming into the front door. So what we do, we provide something called worker pools. Most cloud providers provide it as well. You can actually upgrade, like in this instance, you could say upgrade all my edge nodes first. And then it would shoot those slowly and not take down traffic completely. And then you can come in here and do the internal worker nodes afterwards. But we'll take down one at a time, so we won't shoot your whole app at the same time. But for something custom like that, no matter where you'd run, you'd have to script something like that.
Yeah. So like for managing the infrastructure, Terraform is one of the tools to manage infrastructure as a code. Do you think that would fit this particular sort of use case, or like what other?
Yeah, that's a good question. So the question was, could you use Terraform to do something like that? The answer is yes. We have Terraform APIs. Most other cloud providers do as well. You could easily script that with Terraform.
How does Admiral and the carrier manage all that different configuration you have to have for all the various environments? That's a lot of environments.
That's a good question. I'll get into that in a second. We're going through actually a demo. I just want to make sure. Actually, maybe we should jump into that sooner or later. Don't have much time left. Just want to go through a quick demo here in a second, but I'll save that for the demo. Any more questions? Let me see if I have any more interesting slides really quick. Oh yeah. So okay, this kind of gets into that. So Let's see, we'll skip over a lot of that. Okay, so we're actually getting some internal kind of ops, how we kind of run things. So is this big enough or not? So we use GitHub for everything. We have GitHub Enterprise. We're not on the public internet. It's whatever, but we have GitHub. So I have a sample little app right here. It's a Go app. I'm just going to open up a file and kind of show you how like our CI process works for getting things out to production. So simple little Go app. I'm just going to change some code really quick. If anyone catches that, that'd be funny. Okay, so just committed something to Git. So underneath the covers, we use Travis for everything as well. Travis is wonderful. We have an on-prem version of it that kind of drives our whole CI pipeline for how things get to production. This is kind of simulating the way we do internal microservices. This is a Hello World app, but it's the same tooling we use to get things to production as well. So I'm just going to go to the Travis link it has inside the repo. It's going to start building the app. Did it already build it? No. Okay, while we're waiting for a Travis worker to spin up. One's coming up. Okay, cool. So this is the same process we use to get microservices to production. We have this internal tool where it's called Razzie. We're about to open source it, but it's basically this fancy version of multi-cloud management. So it's the way to manage kube clusters across different clouds, us, Amazon, Azure, whatever, it really doesn't matter. Kube is kube, everything talks the same APIs. So what this Travis job's doing right now is creating a Docker container and setting up a little, if you remember that deployment YAML I had over there, a special one of those, to our CI system. It's going to auto-deploy this out to my kube cluster, and I don't even have to touch anything. Everything just happened with a Git commit. And that's basically how things get to production for us. The way it kind of works for us, I'll kind of go into a real example while this is still building. Let's see. If you're sneaky and want to take down these URLs, they won't work for you anyways, but you're more than welcome to. So basically what happens is we have this fancy little tool that everything's driven off of Git SHAs, which is kind of cool. So we have the definition of different environments. This is probably a little bit overboard, but we have a couple different dev environments here on the screen. It says dev and then a pre-stage environment. I hate that name so much. We have a stage environment that we have, let's see, 6 different prod regions around the world. So Tokyo and Hong Kong, Sydney, Amsterdam, Frankfurt, London, DC, and Dallas. So that's where we run around the world. Our main like MZRs, our main availability zones. We have stuff everywhere else. So, but the way things kind of flow, it's literally, if I wanted to deploy something to prod, I would come in here, choose a new Git SHA. Let's see, grab the latest. That's not a, I'm not going to actually do this. Let's deploy something to the stage really quick. Let's see. I'll hijack our stage environment. Okay, let's take back to an old version of our stage environment. Literally go click request train, start, and all of about 30 seconds that's rolled out to our stage environment. That's literally our CI pipeline. Super, super simple. I'll get into some of the kube stuff it does underneath the covers, but it's basically doing kubectl apply, kube deploy. It's just doing kube commands and deploying everything for us. It's so, so, so simple. That's the really beauty of kube in general. So this finished building, yay. So I'm just going to go through the full flow here, and I'm going to go switch to terminal just because. ZSH fans, anyone? Yeah, ZSH. So I have a cluster, a kube cluster running. Let's see. Let's do kube. Let's go get the kube config for it really quick. Please demo gods. Yay. Oop. Did I log out? There we go. I logged out.
Hey, Jeff.
Yeah.
I'm seeing a lot of Kitch up there. Do you know Jake Kitchener?
Yep, these are actually his clusters. Yep. Yep. Yeah, these are his clusters. kubectl, so these are all the native kube commands now. kubectl get pods. I'm just going to show you this. Come on, internet. I noticed something earlier with the Wi-Fi here. It did not like some of the VPNs. Well, we'll switch to the UI then. Okay. So this is the same cluster. It's named Kitch, and if anyone's familiar with Kube, this is the, let's just switch to this. The Kube dashboard here. So this is the same Hello app that we deployed earlier. Here on the screen we can see there's an IP address. That's from the cloud provider load balancer, so I can click on that, and hopefully it will say hello TriLug Chug. And it does, yay. So I mean, that's a very simplified version of how we get something to production. This is coming out soon, open sourcing, and we're just going to give it away for free. There's no reason to sell it. But yeah, it's some of the powers with Kube. Like, let me just see if I can do this really quick. Let me just get on my phone really quick. Tether. Any questions while I'm trying to tether really quick?
You're going to give away Razzie?
Yes, we are. So I was referring to something called multi-cloud manager. Basically, it's a way to manage Kube clusters across different cloud providers. So if I was a non-cloud provider running something in the cloud, I would not run everything on IBM, for example. I would run a backup on maybe, pick your other favorite company. I mean, what if everything goes down? You always want to have a backup for DR just in case. And so that kind of tooling will help you sync access credentials, sync all your apps across every single cluster worldwide. In this demo, I'm not going to go through it now, but it actually deploys an app out to GKE, which is Google's Kubernetes service as well. So we're friends with Google. We like Google for the most part.
You know, DigitalOcean has a Kubernetes service now?
Yes, I actually haven't read much into it. Google's has kind of been the I guess what everyone's driving towards, and I'd say in some places we outshine them, in some places they outshine us, but it's almost tit for tat there. I like ours, though, preferably, but I have to say this or I'll get shot by my bosses.
Is there a feature or bug you want developers to attack within Kubernetes and fix?
Kube is actually pretty good about open source stuff. Like, go to github.com/Kubernetes/Kubernetes. There is so many bugs out there you can easily fix. There is a notorious guy at IBM, I'm not going to say his name. He loves documentation. His job, like, he loves is fixing docs. He gets free tickets to conferences all the time because he fixes docs. Like, a tip for anyone, if you want to go to the conference for free, go work on open source projects docs. You can go to conferences for free forever for that. Seriously. If you're a good technical writer and know how to write like good sentences, there's a good way to get free conferences forever, honestly. It's a pretty hard profession to do. Nope. So I'm just doing some native Kube commands here. We'll make this a little bit bigger. So we'll try to explain some of these concepts. So kubectl, this is the Kube command line, get deployments. So that's that top level thing I was talking about. So this is my app. I have one instance of my app running, but I can easily say I want more instances of my app. So before I do that, let's go down one more level. kubectl get, I'm just going to do some abbreviations here. Get RS, it stands for replica set. So this is what I was talking about earlier. So you see lots of different ones here. Here near the bottom, that's the one we just changed a couple minutes ago. So Kube keeps these around. Like, I can say Kube scale up, what's that, ending in 47B, and delete the current running one, and it'll roll it back. Super easy. If I want to scale up the current running app, I can say kubectl scale deployment. Let's see. Ignore this -n for now. It means namespace, so you're targeting like basically a way to segment things up. Let's see, the app name, hello app. Let's see, -s replicas equals 10, sure. So 2 instances of the app already up and running. kubectl get pods. There we go. We have 10 instances of the app already up and running. All load balanced, all taken care of. Behind ingress, I had to do nothing. I didn't have to touch Nginx at all. Like, I used to monkey around with Nginx a long time ago. It's not fun messing with it. Doing an Nginx config, like checking, not fun. And typoing, like messing up tabs, I hate it. This makes it so much easier. Just something else really quick. Let's see. So I'm just going to deploy another app really quick. Let's see. So I'm going to run another app. This is kind of just shows how Kube kind of load balances things. So this spun up a little app. It'll basically say the container's name in it, so we can see it's actually on different nodes. So spun up an app. The next thing I'm going to do is give it an IP address. So this is super simple. I can say kubectl. I have basically some scroll back here. I'm just going to pull it up. Expose the app. Let's see. Type load balancer. So I'm going to expose the app. I can say kube. Show me the service is what I was talking about earlier. Gave me an IP address on the public internet. Open that up in a web browser. So I'm going to refresh at the top of the page. You'll see that thing at the end changed there. It's the pod name it's currently running on. So it's load balancing between different pods right there, out of the box for free. You literally had to do nothing. And that took all of 10 seconds to deploy an H8 app. It's pretty awesome. Any questions so far? I can keep talking forever. I know I'm coming up on time at some point.
Question.
Yeah.
So what you just did there in the demo was interesting. So you had an app that was running, and you brought up the app. It was already running, and then you exposed the app. So are you essentially doing a route of a virtual router technology to get that exposed to the outside world? It's like Doctor, you have an external port.
So that's a good question. So the way this, let me just see if we can do this really. kubectl get services.
And how did that work after the app already did a bind?
That's a great question. This is some of the magic of Kube.
Yeah, I mean, I don't understand.
No, this is the great magic. Let me put this at the top of the screen so everyone can see this. Maybe make this a little bit bigger. So at the screen here, I'll describe what this is doing. So the name of the app is Hello App. It really doesn't matter. I expose it as a load balancer. That could be just a service. It could be a node port. Don't ever use node ports. I won't. Node port basically opens up a public IP on the internet. Not a great idea. But this is, so the next thing is actually important, cluster IP. So if you actually SSH into the cluster, that's the overlay network I was talking about earlier. That's a Calico overlay network. It's a private IP space that routes inside the Kube cluster itself. So if you go SSH into one of the nodes, you can go curl that IP address. You'll get back the exact same thing. Behind the scenes, again, this is cloud provider specific, but everyone implements it from mostly the same way. It's a layer 4 and layer 7 load balancer that round robins traffic behind the scenes between the running versions of the app. And then for the ingress controller for like Nginx, I'll talk about how Nginx does this, is when I scale up the app, Nginx sees that change. The controller sees that change. I'll go back to the term controller earlier. It sees that change and modifies, if anyone knows Nginx, it modifies the pool in the Nginx config file on the fly and reloads Nginx on the fly for you and starts routing traffic to the new nodes. Pretty powerful
Nginx
stuff.
Just get bought by F5?
Yep. Nginx is wonderful. HA proxy is wonderful. They both have their own uses. But yeah, so each of these pods, this one might actually be interesting to look at as well. kubectl get pods. So this is going to show all the running. Oh, geez. Okay, there we go. So these are all the running pods. So you'll see IP addresses for each of these pods. So these are the same overlay network, the same Calico IP addresses. So if I went and SSH into one of those nodes, I could literally curl that IP address. In this case, it would be port 31,631 on that IP address, that 172 IP address, and it will respond. Up here at the top, this is kind of interesting to note. Kube will actually rewrite ports for you, so you can say, I want to expose it on, let's say you want to run an SSH daemon for some reason, port 22, and then your app internally could run on support 8080 for whatever you wanted. You can do that. Really cool. Any more questions? I can talk for hours on this. Yeah.
Yes. Does Kubernetes support IPv6?
Yes, it does actually. It does internally, but if your cloud provider doesn't support IPv6 and the load balancer, the ingress, it won't come across. We do. I have AT&T fiber at home, and I see my IPv6 address come across in their logs. It's kind of cool. It's hard trying to trace things because it's like so freaking long, and I hate trying to find it, but yeah. Any more questions? Go play with Kube. And don't use Docker. Sorry if there's any Docker fans in the room. Let me see if I have any other slides I need to go through. If not, that was it. I'll just cover this just for fun. If not, I might get in trouble. We have some big clients that we were supposed to call out. This fancy bank in Australia, they use us for all their banking, everything for their bank runs on our cloud now, which is kind of cool. American Airlines is moving all of our stuff around Kubernetes, which is really cool. If anyone's Mad Men fans, like, always think back to Mad Men. So if you get your airline, your tobacco company, you made it in life. I guess tobacco companies maybe not anymore, but airline's kind of cool. Yeah, banks. Yeah, and actually, a bank is a good one because I guess this is something about cloud. Like, this is something if there's any one for Salesforce that works in the room. I love you because you're blazing a good trail. Like, no one trusts public cloud companies, and Salesforce somehow has been able to con everyone into thinking public cloud is safe, which is awesome. For the most part, it is, and they're getting everyone to move to public cloud, which is great. But banks, yeah, banks are very concerned about moving stuff to public cloud. And then weather company runs all the Weather Channel, the weather company runs all their stuff on us now too, which is kind of cool. But any more questions? Yeah.
So I had some questions regarding pod priority and preemption and autoscaler and all those features. So I was playing around with those features and reading the documentation. One of the things I noticed is when we have the pod priority and preemption and you define a couple of priority classes, and the scheduler might not 100% guarantee your pod exception budget if you have like a bunch of affinity rules in the deployment. So
I know where you're going with this already.
So, like, how concerned should we be in such scenarios, and how should we handle it? And the other sub-question I have on the same path is that, let's say I define priority classes for 3 components, say A, B, C, and A has highest priority and B and C same priority but lower priority, and A has like a bigger pod and B and C has like a smaller pod. And let's say B and C are running, and now A comes along pending. So the scheduler tries to evict B and C together in order to deploy A. But my priority for B and C was, even though lower, their combined priority is like larger for me for some reason because they work together, right? But like, how do we let the scheduler know that? Like, is there any way around that to define sort of aggregated priority?
Yeah, so I just want to post this up on the screen really quick. If anyone wants to take my email or Twitter, and you can send me any more questions, I would be happy to talk more or answer any questions about and Kube in general. Let me just make that a little bit bigger. Sorry, it's not a fun, cool email address. IBM doesn't hand out fun, cool email addresses. They have an IBM.com one, but I'm not cool enough to get one, I guess. It shows how long I've been at the company. I'll leave that up for a second while I answer the question. So the first question was about, so with Kubernetes, you can basically say, I want some pods to run on certain nodes and some pods not to run on other nodes. So think of your basic 3-tier web app. Like, you have your front end, your back end, and a database. You probably don't want all three instances of your front end web app, your node app, running on the same node. That's dumb. You don't want to do that. So what you can do is use something called an anti-affinity rule, and basically says kube do not schedule my front-end web app on the same node. And there are some intricacies I'll get into in a second that will answer your question. So kube has something called, drumroll, anti-affinity and affinity rules. They're pretty cool. Let me make this bigger. Does this bounce out to GitHub? Oh, this is wonderful. The kube docs are great. Again, if you want a free trip, go edit them. Go click a button in GitHub and you can edit them. I've made changes. It's really easy. Actually, if you want a free ticket to KubeCon, you literally just have to make one edit and get it accepted. You can get a free ticket to KubeCon. It's in San Diego coming up soon, and then Barcelona, Spain. So what this says on the screen, this is a very, very simple pod definition, and this is not a deployment. I just want to make that clear. So basically what this says is there's two types of anti-affinity and affinity rules. Required, it's really long, let's say it out. Required during scheduling, ignored during execution. So I'll explain that, and it makes sense once I explain it. So required during scheduling, what that means is the kube scheduler will not start your pod unless that rule is met. So if you say, I do not want my node app to be on the same node as the other front-end web app, if you have a rule like that, it will completely abide by that. However, the rest of that says ignored during execution. What that means is while your app is running, if kube runs out of resources and has literally no other place to stick your app besides the same node, it's going to ignore that rule. The next one is preferred during scheduling, ignored during execution. So preferred during scheduling means if it can place your app on separate nodes, it will, but it won't. If it can't find anywhere else to stick it, it won't not schedule your app. So we usually do that for the most part if for some reason you get a bunch of influx of traffic and you're trying to scale up your app. We don't want to take a 500 error because we don't have enough instances of the app up and running. I would generally recommend preferred during scheduling. There's also two more that aren't here on the screen. It's the inverse, required during execution as well for both of these. That was the first part to your question.
So I heard that that feature is not yet rolled out.
This is out in Kube right now, yeah.
Not this one, the reverse one, required during scheduling, required during execution. That's what the docs say.
Pretty sure it is. Oh, you're right. Yep. There we go. I did not read the docs. And the reason I'm guessing that is it's the kube scheduler. I mean, it's come a long way. Like different companies are trying to put their own like proprietary technology in the kube scheduler and try to make it better. But again, it's all open source. And the reason that's probably hard to do is, I mean, just thinking about cloud resources and trying to not schedule something because it doesn't meet the right capacity requirements. That's very hard, very sophisticated technology. Most people probably will not open source that because we have a fancy scheduler. We do not open source. It's our research team makes it. We don't use it in our public cloud, but we sell it if you want it. That will do that. But I mean, that's kind of like the golden keys of the kingdom right there. But I mean, I've never seen a use where we'd actually need that personally, but I mean, there's probably use cases where you want that. Yeah?
So let's say we are running on Kube 1.12 and we have autoscaler running in the cluster as well as we have got like priority classes defined in the cluster. Let's say some like resources are limited and some deployment scale out makes pending pods come in. And so in that case, scheduler will kick in first and try to kick out some of the lower priority pods and deploy the high priority ones, or the autoscaler will come in first and it will decide like let me just keep the lower priority pods running as well, but add some more nodes to the cluster and deploy the high priority ones over there without disrupting what was running.
There's a couple ways to do that. So the question was, let's say you have some high priority pods, like let's say your HR app that sends out payroll, for example. That's everyone wants to get paid. Like no one wants to take that down. That would not be good for anyone. Let's say you have some high priority apps running, and you don't want to overrun resources on your kube cluster for that reason. There's a couple ways around that. So my preferred answer to that is use an autoscaler that scales out your pods, but also use a cluster autoscaler that scales out with the IaaS provider, whoever your cloud provider is, to scale out additional nodes on the cluster itself. And most cloud providers provide that, that have a cluster autoscaler, and you have like a warm up and cool down period, so you can kind of avoid those sticky situations. I would just say add more capacity.
So question regarding that, let's say, I'm using some infrastructure provider and I have my cluster autoscaler in the cluster, and the way it works is it tries to balance the load between like all the zones. Let's say I have multiple zones.
Yep.
But say my capacity is limited in say one particular zone or pod by my infrastructure provider, and the autoscaler does not have any knowledge of that. So it will basically try to scale up, wait for a specific amount of time before canceling the operation, whatever specified.
Yep.
But at the end, we end up with pending pods and without getting scaled up because it doesn't have any knowledge of infrastructure provider.
So I'll repeat the question. So the question was, let's say you have a multi-zone cluster running, like let's just say 3 zones in Washington, D.C., for example, and one of the zones doesn't have enough capacity to scale up. I guess the first thing I would say is, if a zone doesn't have enough capacity to scale up, it's not truly a cloud. I'll go into that a little bit more. So for us, we do something called worker pools. So we don't allow imbalanced number of workers between zones. So like if you have a worker pool that you say want 1 node per zone, or 1 node, it's going to spin up 3 nodes for you. If it's 3 zones. So you can never have that imbalance. We will never let you do that. It's for that exact reason. So you don't screw yourself like that. But I mean, we don't let you get into a situation where there's not capacity to back that. Some other cloud providers might let you get in that situation, but we don't let you get in that situation. I mean, that's the whole magic of a cloud. It's supposed to be limitless. Everyone knows it's just a bunch of servers sitting around anywhere, but I hate that term cloud so much. I hate when certain companies use it on TV. And we're one of them too, so it's fine. Yeah?
Do you have any comments about running bare metal nodes versus virtualized nodes?
Great question. Yeah, so I'll repeat the question. So the question was using VMs versus bare metal nodes that run Kubernetes. So we support both. There's use cases to use both. So our VMs specifically, they offer burst bandwidth up to, I think it's like 4 or 5 gigs per second on them. They're much cheaper. Like you can get a VM for, I forget what the pricing is, but VMs are much cheaper to run than bare metal. But for bare metal, you can get higher throughput disk rates. Like you can get giant like RAID arrays of like RAID 10 of like brand new SSDs, the NVM2 SSDs. Like you can do crazy stuff with that. And then you can get the new fancy Tesla cards inside of the bare metal nodes. And Watson actually specifically does this. They run these giant bare metal nodes. They basically go into our IaaS provider. They buy all these fancy NVIDIA cards that you can't get because they buy all of them. You can get them, but they're hard to get. But they basically have these giant clusters running worldwide. They're using GPUs to do image recognition, and they use bare metal nodes for explicitly that. But yeah, bare metal use case nodes using GPUs. Kubernetes actually supports scheduling specifically the bare metal nodes. So if you have an application that works only on bare metal, you can say, hey, Kube, schedule this to a GPU node only. So that's really cool to do that. And then like we have a couple logging providers, cloud providers that run logs publicly, and they run on top of us. They need giant bare metal nodes. They have these 52 core machines that have 242 gigs of memory, 40 gigs of bandwidth, and then it's a RAID 10 array of 9 SSDs that have a terabyte storage each of them. So like, that's very expensive. That's like $10,000 a month for one of those. But I mean, you can do crazy cool stuff with bare metal. But internally, like everything inside of IBM Cloud runs on top of our platform, which is kind of cool. So we dog food everything. Most of all service teams run on VMs, actually. It's just cheaper. And you don't need that crazy SSD performance or GPUs. I mean, for most cases, a gig link works for most people. If not, just spin up more nodes. Does that answer your question? Yeah.
So a complete new question, and I know you got a whole bunch of
No, I love-
spewed throughout your audience here. I was fascinated by the K3S, the Kates for Raspberry Pi.
I think I actually still have it open in my web browser.
And,
Oh, I do.
I'm wondering, when you're talking about bare metal, to what degree there's a reliance on the kernel for everything Docker, and obviously Kubernetes is built upon all that, container stuff. So it may not be just Docker, but it's Linux containers underneath the covers. And so what degree do you need the kernel versus running bare metal? Because when you talk about an NVIDIA processor, GPUs running, can you imagine them running a little Linux? I can't. So somebody has done some significant customization there, right?
Yeah, so we actually helped build the GPU provided for NVIDIA specifically. But the way that scheduling works for a GPU is Kube will actually go schedule it to the GPU scheduler instead of running it inside the Linux kernel, which is pretty awesome, if you ask me. I don't know much about that stuff, so I'm not going to go too far deep into it. But we have seen issues with, I'll say, Ubuntu 16.04. What's the kernel? 4.4, I think. We've seen lots of issues with IP tables. There's kind of like a max throughput you can hit, and we've battled IP tables left and right. Like, IP tables is the bane of our existence. I hate it so much. But IPVS is another great solution. I think it was Comcast or whoever owns them now. They use IPVS pretty exclusively in their Kube setup. But IP tables in 18.04 and the latest Ubuntu 18.04 and the latest kernel works pretty good right now. But it really doesn't matter what the kernel is for the most part. Long as it's the Linux binary. And the cool thing with Docker containers, I guess I'll say Containerd specifically, is we don't really build on top of a specific OS. We use something called Scratch. It's actually, has anyone heard of Scratch?
The base container image that just has core util or something?
It's even less. It's literally, if you go pull it down on Docker Hub, it's empty. There's nothing in it. So it's a great little security thing. You literally compile a binary, you stick it in an empty container. It has nothing besides your application binary, so it's super secure.
So isn't there a layer of communications and monitoring of a Kubernetes app inside a pod that's running in a container? Or is all of that telemetry of it operating correctly and what have you being done from the outside?
So Kube does most of that for you, actually. So let's look at this running app really quick. Let's refresh this. I'm still on my phone, maybe. Yeah. Come on, Verizon, let's go. So here's my running app. Let's go look at the pods. Oh, I should switch back to NC State Wi-Fi. So these are all the running apps. So Kube itself basically has some basic state metrics of each app. So how many cores it's using, how much memory it's using. You can do health checks. You can check a file inside your container. You can check. We mostly do HTTP health checks instead because you can do way more with that. But Kube will constantly make sure your app is up and running. If it's not, it just shoots and replaces it.
So it'll make sure it's up and running as long as the app is doing something with the internet.
Yep, exactly. And then
so it's got to be RESTful or some other.
It doesn't have to be RESTful. Like if you have a stateful set, sometimes long running apps, just checking a .sock file inside of an application to see if it's live, that's great for a lot of things like daemons that are running. Is there a socket file there? Yay, there you go.
Okay, so going back to the NVIDIA array, I can imagine them doing something compute only. So
they don't want to build a cloud, actually. I'll tell you that.
Yeah, I can't imagine them. They're not building a cloud. They're building a KDB or something, some mathematical computation or whatever, and they're talking to it probably over their local bus, in memory, pod-to-pod communication. They've put together some kind of GPU memory communications mechanism.
So that actually gets handled through Kube itself. There's an abstraction layer between the Linux kernel and everything running inside the same pod. There's basically, starts going above my head. There's basically some Linux black magic stuff that happens that, sorry, I don't know that part. That happens, like everything communicates inside of itself there. And it's voodoo black magic to me, it just works to me. Any other questions? I can keep showing stuff.
What is the most valuable thing, like what resources have you used to learn Kubernetes over the years?
Running it yourself. Dog fooding it a lot, honestly. The kube docs are actually really, really good. Really, really good. The kube community has actually a public Slack, and they're all kind of split up in this. They're called SIG, special interest groups, and most of like the core committers will respond to anyone's questions in there. So if you have a question, like go ask. Most people will respond to it. We have a public Slack. You're more than welcome to like come and hang out in ours. I can post a link to that if anyone wants. I'll add it to the presentation when I upload it. But just using it, like, I mean, we started using Kube, Rafa, how long ago was it? 2 years ago? Yeah, 2 years ago, and like no one knew Kube. Like we came from running this giant mess of a OpenStack cluster that provided like a multi-tenant Docker service. No one knew Kube, and then now everyone's Kube experts. Just use it. But I mean, a lot of things that in the community that's kind of hard to figure out is like running an app in prod. That's not talked about that much. That's where you can get in trouble with Kube and what's, I guess, the secret sauce to being successful with it. Yeah.
So running things in production, what kind of security concerns do you get dragged into?
That's a great question. Everything. So we had a new CIO come inside of IBM, and like we used to have like these crazy, I hate these devices so much, and Rafael will attest to this. They're called Viatas. They're fancy Linux firewalls, and I hate them so much. They suck so much. But so we basically convinced our new CIO that Calico is awesome for firewall protection for basically all of IBM Cloud now. It's literally IP tables underneath the covers. So by default, we lock down everything. Nothing's opened up. But security concerns for running something in production, never, never, never expose something with a node port, ever. Don't ever do that.
So if you're, just to follow up on his question, if you're running a multi-tenant cluster and you've got this security vault, do your tenants care that all of the secrets are in the same security vault?
So I guess what are we referring to as a multi-tenant cluster, for one customer or for all of our customers?
Well, no, but if you're, okay, so each tenant spins up their own cluster.
Yeah.
Okay.
Yeah. So yeah, Joe and Sally will never have the same cluster.
They'll spin up their own Kubernetes cluster.
Yeah. Okay, Les.
Sorry, to get back to the security thing.
Yeah, I want to delve into that a little bit more too.
Yeah, IBM, well, we're a sales company, right? So we need to have our customers be happy, and our customers need certain things like PCI compliance and ISO compliance and HIPAA compliance. So some of the stuff is at the container level, at the infrastructure level, at the cluster level. Some of it is us as well, but we are compliant to security.
Name your favorite acronym. Like we have it. Like most other cloud providers have it too. But there's some general like do's and don'ts with running it in production. Like node port's one. Don't ever do that. It's an instant way to get hacked. Don't expose. Be very, very careful with RBAC. RBAC is Kube's like basically auth-z strategy. Be very careful with that. You could accidentally open up all your APIs to everyone. That would be bad. Be careful with Calico. Always use an ingress or load balancer. Those are really the big ones, though. Yeah. Node port.
Any parts of your clusters you give your customers that you lock them out of?
We do, but we provide some docs on how to get around it. We strongly discourage you to do that. There's literally a line in the docs that says, if you do this, you're avoiding the terms and the conditions. We will no longer support this. But you're more than welcome to do it on a dev or test cluster, but Just don't do it on a production cluster. But yeah, we lock you out of SSHing into it. We lock out the root password. We turn on SSH only with keys. We don't have the key to it. It's stored in our key protect provider that's backed by this crazy HMAC. Like, I don't even know how that works. Like, you delete a key and everything's gone type of thing. SSH is locked out. All the ports to the VMs are turned off in IP tables. You can't get into it basically at all. There's ways you can turn on things back on, but I wouldn't do it in a prod cluster at all, though.
You should let your customers run containers as root in their
We do,
environment?
yeah. So you can run privileged containers, yes. So a privileged container, just to go into that, is basically running your application as root. And certain things, you need to do that. Like if you want to scrape like var log, for example, you need to run that as root. But yeah, there's cases where you want to do that, though.
There's also a vulnerability advisor. That's basically a service that we have that we can use to scan your pods and applications for whatever is out there.
I could happily talk security with you all day because I literally deal with it every day in my job. But yeah, I mean, yeah.
So, going back to node ports for a minute, okay, never ever open a node port.
I mean, for a dev cluster, it's fine, yes.
I've heard about that, a lot of the, like, for instance, I'm going to compare it to OpenShift.
Yep.
So, like, ingress can, for OpenShift, it's basically like that's the only way you can access like a non-HTTP running service. Is there a way in Kubernetes to expose something like that?
Yeah. So I'll talk about our load balancer and ingress specifically. Our load balancer can take any type of TCP traffic or UDP traffic. So you can connect UDP traffic over the load balancer. I literally run an rsyslog server on a kube cluster because I can, and forward logs off my home networking equipment. I just run syslog and forward them all off to my kube cluster because I can. Why not? And I get free logs from work. Yay. Awesome. But also our load balancer, our ingress actually supports UDP as well. It's really weird. It works. So you can actually do UDP over a load balancer as well. And we do like TLS termination for you. Like most cloud providers will do TLS termination, give you domains with an ingress. So like when you spin up a cluster with us, we'll give you, what's this? Let's look at this cluster. We'll go back to Kitch because he's been talked about so many times now. So this cluster, it's called kitch.useast.containers.appdomain.cloud. So if you spin up an ingress, you can say, I want to expose my app called www on that domain. Like, we'll give you the full wildcard cert. We'll generate a cert for you. We'll give you that wildcard cert for that domain. You can do whatever you want. Most people will just CNAME to that. AA.com CNAMEs to that underneath the covers, but they go through Akamai, so you won't ever see that. But
How are you guys with the CIS, Center for Internet Security Benchmark?
yeah, so we white label something called CIS. It's a Cloud Internet Services, yet another acronym. We white label Cloudflare, which is an awesome non-evil company now. Akamai, it's great CDN, but Cloudflare is an awesome company, and we partner with them. We basically hand out free TLS, load balancing through them with all of our kube clusters now.
Let's talk about the Center for Internet Security.
Oh, sorry. There's too many acronyms. I'm so sorry. I actually don't know the answer to that question. You can email me.
Yeah, it just gives you a score. Sorry, what question? Yeah, it's what is it? It's they just make standards, and we have to implement standards. For example, log message can only be read by root, so 0600, for example. Well, not 600. You know, you get the idea. So pages and pages and pages and pages worth of stuff like that.
Yeah.
I'll just go throw this out as well. Like, this is actually really important when just choosing a kube provider in general. Look to make sure they're certified by KubeMark. It's an open source thing by Kube itself, the Kubernetes community. Make sure they're certified by KubeMark. Like, don't run on a provider that's not. We are, and most other people are, but that's something important to pick. I'm trying to keep this vendor agnostic with doing very minimal pitches. I don't like doing vendor pitches that much. It's
You're doing
weird.
good, because you'll say, we do, and most of the people do too.
Yeah. I did this previously. I don't like talking about vendor stuff really.
So last week with RSA, there were a couple of things about container escape. Is that something you guys worry about?
Yes. Generally, just don't run something that's privileged. That's a bad idea unless you need to. That's when you start getting in weird situations. When you run something that's privileged, you start introducing weird stuff. So container escapes we actually have our CIO team, they do constant scans. They're trying to break out of our service all the time. And they have internal VPN access, and they're trying to break into it internally. No container escapes, nothing's ever happened with that. But from a customer side, if you ever had a container escape on your own cluster, it would have been something you would have configured yourself or shot yourself in the foot with, honestly. But the worst case solution would be your account only would be affected, your VLANs would be affected, your applications, no other customer would be affected.
Because everybody is isolated to their own.
Yeah, so everyone's kind of walled off on their own VLANs. Like, I'll be on VLAN 10,002, and could be on VLAN 11,000, for example, and they're all blocked off.
Well, one of the things people forget about containers is that you start off with most of them start off with a Ubuntu layer or some other operating system layer, CoreOS or whatever. And so there are security vulnerabilities at the operating system layer that occasionally you got to keep up and upgrade that layer as well. So just keep that in mind.
So this is what I was referring to earlier. This is literally like the best container if you're running a binary for your application. Run Scratch, please, if you're going to run Docker or Containerd. Run Scratch, it's awesome. Don't run Alpine. Alpine's great, but run Scratch instead. And what we do, we need like a couple utils like ping or something copied in. So we literally copy in ping from an Alpine container and have like 3 binaries in there. We don't even have top inside of our containers, which kind of sucks. Any other questions? I want to be respectful of time and not pissing off NC State. Any more questions? Shoot me an email. I'll put this back up. Where was it? Yeah, thank you.
Thank you.